let me know if that pops up. You good?
Yeah, it hasn't asked me for consent. It's fine.
Weird. Okay. Right. So we're going to go over the target costing problem for fans. And this way, while you're on with me, whatever questions you ask will probably represent some of the questions that whatever other student, ends up asking down the line. So that works out. So can you see my screen?
Yes.
Oop, just kidding. This is not what I want. Where is it? I closed the budgeting one. See if I'm... Okay. Now we're good. So there is a lot of text and it's kind of scary, but I'm going to walk you through sort of like what this is conceptually before I dive into the problem itself.
Okay.
So the thing with target costing is you're trying to figure out, based on what the retail price of this item is, how much space there is for the target manufacturing cost. So above here, like I won't dive into reading the problem right away, but here you know that the retail price is 150 and the market decides that. And you also know that Home Depot, they take 30% of that. So that means that there's only $105 in addition to removing all these things. There's only $61.10 for your fan to cost. If your fan costs more than that, you have to start cutting costs. So that's what the whole problem's about. Like keeping retail in mind, keeping the end of the supply chain in mind. How much can this cost in order to sell? Because one thing is selling it direct to consumer and another thing is having to go through some retailer like Home Depot. So that's what this is all about. Down here, if you were to do the analysis on our end, manufacturing the whole thing, you come to find out that once you add up the blades, motor, and shaft and all of the overhead, it actually comes out to be bigger than the target cost that you figured out above. And that's a problem. So currently, your manufacturing cost adds up to $69.65, and that's $8 roughly above this. And so what we're going to do is we're going to try to figure out how we can get that number down in order to fit. So if you think of it kind of like a pie, this $69.65, that piece of pie is too big for the whole remaining in like the pie tin. This kind of represents the whole pie with a little piece missing, but our piece is too big to fit.
Okay.
So in order to get the cost down, you're going to start thinking of overhead items first, operational items, and then you'll think of materials. Because if you can fix this problem by just having a more efficient factory or a more efficient manufacturing process, that is way better than having to dive into the materials and like figure out, can we cut costs on the blades? Can we cut costs on the motor? Use different materials, different suppliers, things like that. So that's like plan B. We'll put it that way. Plan A is dealing with the overhead stuff.
Okay.
So this right here, the manufacturing cost where it adds up to $69.65, they just copied that into the next tab. That way you can reference it. So this is all the same.
Okay.
Now, in the current scenario, they currently have 40 units per batch when they're processing everything, and they currently have 10 unique parts. The things that they're going to try to do to improve the operations to cut down on the overhead is by increasing the batch size and by cutting down on unique parts, because those things have an impact on these various activities, which ultimately impact your bottom line of the manufacturing cost. So like this, like I said before, this is plan A. I think that's the best way you can think about it, because it's like you really don't want to get into plan B, but plan B is the second half of this problem on the exam. But like in real life speaking, you're going to hope that this all ends at plan A.
Okay.
So in order to increase the batch size to 60, you're going to do a little bit of analysis here. And so up here, if your quantity is $300 per batch, $300 per batch, 40 batches, they did a division to figure out how much it is per unit.
Mm-hmm.
And when you change this to 60, when you do the division down here, it goes down to $5. So it goes down by $2.50. When you do a similar analysis for the second thing, because it's unique parts times batches, you do $21 per batch divided by 40 batches times the quantity of unique parts. Again, you're just going to change this number to 60, and when you do that, it goes down to $3.50. That's a cost reduction of $1.75 for an overall cost reduction of $4.25. But what you notice is even though this number went down by $4.25 from the original, you're still $4.30 from your target. So you're like, okay, I'm not there yet.
Okay. And I'm the one that chooses to go for increasing batches instead of like, I don't know, like looking at other things like parts and units and unique, whatever, like number of parts, number of units, like.
Mm-hmm. But on the exam, they should tell you, like, okay, so in the question, they mentioned that you currently only have 40 units per batch. What would happen if you increase the batch size to 60? So that what
Okay.
if moment, they're going to walk you through it. Like, it's not going to be up to you to like think of this on your own. They are going to make this a question. So when you do that, like I said, you get down to this number, which is great, but you're still not there yet.
Mm-hmm.
So then when you reduce the unique product quantity from 10 to 8 by using the same screw or washer sets for all three assemblies, this is referring back to the overall question. I just find it easier to kind of tell you what was in the question versus read through the whole thing because you're not going to remember it anyway. If you reduce the unique product quantity from 10 to 8, you see further reductions where it says unique. So before we were dealing with like this number and this number because they both said batches, but now we're dealing with this one and this one because they both say unique. You're going to see that this changed, and this changed. So you have savings from part A and then savings from part B.
So we're continuing to use like a bigger number of batches, and now we're reducing the unique product quantity, like together.
Right. Mm-hmm.
Okay.
Like these aren't two separate scenarios. These are overlapping scenarios now. This is both increasing the batch size to 60 and reducing the unique product quantity. Once again, you're here. So still not there yet, which is kind of annoying. So plan A, it got you closer, but ultimately it failed. So being that you're still $3.32 off, we have to shave this number off by attacking the blades, motor, and shaft, the materials within this problem, because this is the thing that didn't change. These things stayed the same in both operational scenarios that you fixed it. But now, because we're still off by this amount, this is going to have to come out of here somehow.
Okay.
So if you were to add up these numbers together, it comes to 3650. And what we're going to try to do is we're going to try to get these down by subtracting this. So like these three things together, when you add them up, they have to be 3650 minus the $3.32 that this number goes over, because we've already done everything we can do here. The only thing left for us to do is to cut this, which adds up to 3650 by this, and then we'll arrive to the target cost.
They're gonna ask us to do that?
Yep.
Okay.
So I think we're all set so far.
Yes.
In order to cut down on this, we're going to kind of get into a sort of messy analysis, but honestly, once you memorize it, you're going to be okay. So this looks ugly. I know it does. So I'll just try to go through it slowly for you.
Okay.
I got to move this thing real quick. So, okay. Here's the thing. When you have these three different pieces, the motor blades and shaft, you're like, okay, well, how am I going to cut costs? Like, how do I know what things I should be sacrificing versus what things I should maybe even be reinvesting in according to what the customer actually cares about? And this is all about the customer, because if you were to go back to the very beginning, we know that this $150 price tag is ultimately determined by the market, determined by customers. So you're only going to cut costs according to what the customer is okay with. So your first thought might be, okay, like, let me send out a survey to my customers about what they care about the most, motor blades and shaft. Like, what do you think is the most important? But the reality is that the customer, they don't know what they care about in terms of the components to the product. What they do care about is the features. So what you're going to do is you're essentially going to translate their scoring on the features into their scoring on the individual pieces. So if you remember back to ABC, how you had like all these different line item costs and you converted it into activities, it's the same type of analysis. So over here, this is the survey score, 1 to 10, rank it. If you took this 9 and divided it by 27, you find out that customers think silent operation is ultimately 33% or 1/3 of the benefit of the product overall. So that's where these numbers came from.
Okay.
You take the survey score percent and you multiply through the components contribution, which this is given to you. The stuff in black is given to you from the problem. You're like, all right, well, silent operation, they say it's 1/3 of the overall benefit of the fan, right? I know, because I make this fan, that the silent operation feature is 60% due to the motor and 40% due to the blades. So you're just going to split this 33 into 20 and 13. And when you do that splitting all the way across, you figure out what people care about. But you can't ask them what they care about in terms of these pieces because they don't know. Does that make sense?
Yes, but I could also do it like 9 times 60 and then 9 times 40 and then like get different numbers, not percentages, and then convert them into percentages, right?
Yeah, I think you could, but I think this is easier. Like ultimately you can do the steps in whatever order as long as you arrive to these percentages.
Okay.
So once you have the value percentages, you're going to compare them to the current cost percentages, and this is where the final analysis starts to take place. Because like before, you're like, okay, $12 out of $36.50. This came from question 1, this $36.50. Remember how we added it up on the previous tab?
Yeah.
I know that 12 is, roughly 1/3 of the overall price, or the overall cost, sorry. But how should I reduce that? Again, we're going to reduce it according to the value that the customer said they value it at. So you know that if the customer actually values it as 26.3% of the overall product, we have to cut this cost. It has to go down. Here, it's a little interesting because it turns out the customer actually cares more about the motor than it currently costs. So we're going to reinvest funds that are available at the very end. And here we're going to reduce the cost of the shaft, because if you look over here, the shaft is very small pieces of these two things, and then people don't even care about them that much. So it's actually not surprising that, adding these two together, people don't really care what the shaft is made of as long as it works. So you're going to reduce the cost from 17.8% of the overall cost to 10% of the overall cost.
Okay.
The more you stare at this, the better it will get. So here, I'll show you a little bit at the top again, actually, because you want to see this part. The two reductions are simple enough. You're going to put those down here immediately, and those are going to go into the final calculations. This 960, this 365, 960, 365, those go down immediately because those are both reductions and it's easy enough. So these are some of the solutions to that. But when it comes to this one, you know how I said reinvest available funds at the very end? The reason why you do it at the end is because if you multiply this times this, because that's how they're getting these costs.
Yeah.
I don't like this formula. I don't know what they put in there, but 26.3% of 3650 is this. Instead of 32.9% of 3650 being $12, you're going to see the cost reduction there. If you did the same process with this 63.7, you'll still arrive at 3650, which ultimately means no costs have been cut at all. So that's why you're going to leave this for the end, and you're going to actually solve working backwards in order to figure out what this can be, because it's like, all right, the motor was originally $18. If we reinvest everything so that people, so that it costs exactly how much people value it, we're not going to cut costs at all. So what we're going to do is we're going to save this chunk for last.
Okay, what if there was one of the materials was like, don't change?
They'll let you know at the very end.
But then how would I calculate that? Like you're
If the
saying like,
material can't be changed.
no, like for example, when you look at the value indexes, you either know if you have to reduce, to increase, but there you can also like keep it, not change it, right?
Right.
And then like if let's say the 63.7 was let's say the motor was not change instead of reinvest available, how would I calculate that?
Like just the same.
Yeah, like if the value index was like 1, so you wouldn't change.
Then you just wouldn't change it. The only ones that you're going to solve for at the very end are the ones that need reinvesting.
Okay.
Or like improvement, basically.
So it'd be $18, or it would be 63.7% of 36.5.
Yeah, so it's not going to be the 23.25 because that gets you back to 36.50. But when you go down to the bottom, notice how these two in teal are right here because the cost reductions are simple enough. That's good. We need to cut costs. You set your bottom at 61.10. This came from the previous tab. This is the part we're not changing this time. Remember when we increased the batch to 60 units a batch and then decreased the unique products to 8?
Okay.
This comes from the previous tab. So this is all just going to stay exactly the same, copy paste, but you're going to set the bottom at 61.10 so that when you subtract all these things and you subtract the two teal ones, this green one is 19.93. So you're only going to reinvest up to the available space within the target manufactured cost. So you are going to increase the price of the motor. You're going to go from 18 to 19.93. You're not going to go all the way up to 23.25 because if you did that, you wouldn't hit the target. And ultimately, it's about cutting costs, not increasing them. But you will increase it as long as you have space. It's just lower priority.
Okay.
So this note, it says solve for missing value, reinvestment, not cost reduction. So how much space do we have left in the target cost? That's why, because it's with this. These two teal ones, simple cost reduction. And all of this, if I could make like a arrow or something. Let me see if I can actually put that in because I'd rather in there. You know what I want? It's like the bracket thing. Okay, this one. So these come from the previous tab. A and B. Because if we go over here, it's the same as this. It literally came from right here.
Okay, there's just one little thing I just don't understand.
This is what this is about. Slow me down.
If we did need to change the number, okay? Not because of the, like, I don't know how to explain my question. So when you look at the value indexes, it can either be smaller than one, bigger than one, or equal to one, right?
Mm-hmm.
And depending on that, they will be like either reduce, reinvest, or not change.
Yep.
And if there were two reduce, and one not change, what value would we use to um calculate the new like cost of the materials? Would it be $18 or would it be 23.25?
No, it would be theoretically, right? If the value index came out to be 1, you just simply wouldn't change it. It would stay at 18. But the thing
Okay.
is, it will never be reduce, keep, reduce, because mathematically speaking, you can't have two reductions and then have it be the same percent. Like if this was 49.3% here and both of these reductions remain the same, you would not arrive to 100%. So the scenario that you're referring to would actually be like a reduce, keep the same, and then reinvest.
Okay. Okay.
So you don't have to worry about that scenario happening because it can't happen mathematically. I don't know if there's ever been an instance on the exam where that there has been a value index of 1. It could happen, but what's more likely is if there is something that says 1, it's going to be like under 1 and then over. So that way
Okay.
you know which one is the reinvestment one.
And is it just like one or is it from 0.9 to 1.1?
Yeah, I mean, if it's a little outside, you can reinvest it accordingly. Like for example, if this was like 50, I would just reinvest it immediately because it's
Okay.
a fraction of a percent. You know, like you'd go from like $18 to like 18.50, that would be fine. But the one that you're really looking for is the one that's over a value index of 1 because that's the one that you need to solve for at the end. Once you drop this thing in, you know, and you have these two reductions, or maybe it's the reduction, keep the same, you're going to solve for the one that needs the reinvestment activity.
Okay. I got it.
Yeah. And then you get to this 6110, like, I'll just pay, like, finally, you made it.
Okay. I get it.
Yeah.
Not that bad.
It's really not that bad, but there is so many steps, which is why, like, you really need to make sure that this is on your cheat sheet or something. And
The
preferably
whole
color coded.
the whole thing.
Yeah, all 3 sheets, because
Okay.
you're going to forget, you know?
Mm-hmm.
But
Okay.
so all of this information, these exhibits came from the previous text and stuff. Like here are the same exhibits.
Yeah.
Um, at the very end, you know how I said like there might be an open response section to all of this in a way.
Mm-hmm.
When you're getting into the cost cutting and everything, at the very end, they might ask you a management question, which is basically like, okay, in written sentences, how would we actually go about cutting costs? So like the revised manufacturing cost here, like how are we going to get down $2.40 lower to 960? Some of the suggestions in this problem is considering 3 blades versus a 4-blade configuration. Or you can push for a cost reduction in each blade of 60 cents, and that would require you to renegotiate with your supplier or maybe changing materials.
Okay.
Same thing here. Cost reduction has to be achieved somehow, but you still need to make sure that it has low maintenance and appearance because the shaft still takes up part of these two. Like whatever changes you make, it can't really affect your feature because if your cost reduction actually like worsens a feature to the point where people notice, I guess you could put it that way, then you're kind of doing things wrong.
Okay.
Ultimately, like I ran through all of this in 30 minutes, like almost exactly, but it is going to take you some time to put all these numbers down. So if I were you, I would try to spend maybe like, I don't know, 38 minutes on this part of the exam. Some of this stuff was copy and paste, like this was copied and pasted in, so it's not so bad.
Should I, I mean, for the target costing, would you say like this would be the whole question?
This is the whole question. Like, just study this thing. This is all you need.
Okay, well, what about case A?
Case A, I think, was actually number one, which is just calculating the target manufacturing cost.
Is it not? Wait, I have it with me. I think it has like questions. Wait, it asks like, yeah, it's the first part to calculate the target manufacturing cost, but then it asks like, what is the dollar amount of the product will contribute to sales? They asked about cash
Okay.
inflow, and I have no idea how to do that.
It's talking about this stuff at the very top, the stuff that there's no information for some reason in this file, but you're going to be okay. Make sure that you have that so that you can figure out the beginning. Because, yeah, case A will be relevant, but they'll tell you the pieces that you need.
Okay, then the other question is, what is the annual amount that the product contributes to cover marketing and administrative expenses? And then like the solution is them just like calculating all the costs without the marketing and administrative costs. And I don't understand like how that answers the question. I actually don't understand what they're asking and how to calculate it.
I think so. They wanted to know how much of the price sold to Home Depot is covering this.
What is the annual dollar amount that the product contributes to cover marketing and administrative expenses?
I mean, off the bat, like here it says that it's 20%.
Okay.
So you could say that 20% of this number multiplied by however many units they sold through the year covers this. But like generally speaking, if you're talking about like contribution margin and
They're talking about contribution margin. So like what they did is they calculated the contribution margin without the marketing and administrative costs. And that's all they did. But I don't understand like how that answers the question.
yeah, it's a little funky. I don't think they'll be asking you that on the exam because it's kind of sounding like it's like connecting the dots from other things that you've learned and it's not getting to the main part of the problem. I don't remember that being on the exam personally.
Okay.
Yeah,
Then
you should be okay on that.
yeah, I'll just have it on my cheat sheet.
Hmm.
Whatever. Okay.
Like here, they're trying to show some sort of comparison, or well, maybe this is what they're trying to tell you that marketing and admin cost is 20% of the selling price to Home Depot. So like maybe it's not in terms of what you're talking about, but because I'm trying to see like the contribution margin, it should be all of this stuff, if I'm not wrong, added together. Because right, like if you did this, which is the price, and you subtracted the variable costs, you would get a contribution margin which is equal to these fixed costs. And whatever that number is, it should be covering the marketing and admin costs somehow. But
Okay.
it's a little weird because you're dealing with supply chain, so it's kind of like this is the selling price instead of this being the selling price because this is your selling price to like manufacture, I guess, but then this is the selling price to Home Depot.
Okay. I get it. It's okay. I believe you. Beyond the
It's gonna be all
exam.
right.
Okay, thank you.
You're welcome. Do you want to see my file for budgeting? I can just email it to you. That's a lot easier.
What is the file like consist of?
It's